Okay, looks like it's a easy part 1, possibly followed by a medium or hard part 2 tomorrow. Alright, Trionic array part 1. You are given an inter-array nums of length n. An array is trionic if there exists indices 0, less than p, less than q, less than n minus 1. So p and q are just consecutive, kind of ordered, well, not consecutive, but ordered indices, such that near nums from 0 to p is strictly increasing, nums from p to q is strictly decreasing, and nums from q to n minus 1 is strictly increasing. So the p value is kind of overlapping, or the value of index p is overlapping between those kind of subarrays. Strictly increasing, so this implies that there's no consecutive values that are equal. I'm sure. Or actually, that also implies that, yeah, you can't have consecutive equal values because then it would not be strictly increasing or decreasing. Okay. So like 135 is increasing, 54 is decreasing, or 542 is decreasing, 26 is increasing. Okay, so what's the question? Return true if it's trionic. Sure. So I think this should probably just be kind of 3 consecutive for loops, something like that, where each for loop has a return false kind of short circuit logic in it. No. Maybe the first for loop is just going to go to the first index that is not increasing, at which point it should be decreasing. I think the index variable should be outside of the for loop since it's going to be kind of global throughout. So let's say let's say while, how do I want to do this? I think I want to do something where it's maybe, I don't know. I guess I probably need a variable for the length of the array. So while index is less than n, and I guess it might be index plus 1 is less than n, and it's increasing, so nums at index is less than nums at index plus 1 index increments. So it's going to be index 0 goes to 1 goes to 2, at which point 5 is not bigger than 4, or 5 is not smaller than 4. So it stops at 2, so here it should be expecting decreasing. I think I do need to check that this hasn't already reached the end. So here if index is index plus 1 equals n, I guess so. Then return false. Okay, and then here it's while index plus 1 is less than n and nums at index is greater than nums at index plus 1. Index plus equals 1. And then here index plus 1 is equal to n, turn false. Well, index plus 1 is less than n, and nums at index is less than nums at index plus 1. And here, I think I want to say if index plus 1 is equal to n, then it returns true. Otherwise, it doesn't work. So return basically index plus 1 equals n. Let's go ahead and just guess that that logic works optimistically. 2, 1, 3. So why doesn't this return false? This thing's returning true. So it's saying 2 is increasing, and it's saying 2, 1 is decreasing. 1, 3 is increased. Oh, I guess this thing, you can't have 0 and p be the same, I think. Yeah, 0 is less than p. Okay, so I think the first thing here is if index equals 0, or that. So that guarantees that it moves at least once. So here, how would I guarantee that it moves at least once? Because p has to be different from q. It needs to guarantee to move at least once. But just do index plus 1 here. I think that's probably fine, and then no, it's not fine. Because the middle section could be something where instead of going decreasing, it's going equal. Yeah, could be going equal. I guess maybe I can just do a comparison right here. If nums at this current index, that is basically p, is greater than, less than or equal to nums at index plus 1. I guess the only way this doesn't work is if this p is equal to q here, I think, actually. So maybe I just do equals. Return false, else index plus equals 1. I think that's right. Because I guarantee that it's not increasing already based on this thing. And I guarantee that it's not just equal based on this thing. So therefore index and index plus 1 has to be decreasing. So then I bump it up. I think maybe this works. I think maybe this works. Okay. Let's say this is for Let's say this is for the first subarray, and this is just the middle section. This is for the second subarray. Why did... Okay, yeah, there was the increasing here. What? Why was I able to just do a +1 equal? And this one's for the third subarray. Actually, I feel like there's something missing here. Okay, I incremented the index +1 here. It's a transition from P not equal to Q. Then I didn't transition another one here. I think ooh, that's pretty tricky logic. I think because there's a guarantee that, I don't know. 2, 1, 3 doesn't work. 2, 1, 3 doesn't work. Q has to be great. I think I guarantee here that there has to be 2 elements in this last portion, because this last portion just can't have this index right here actually be second to last at that point. So there has to be third to last here, so therefore this thing has to guarantee that there's 2 values in this third subarray. I think that's the logic. Oh, well. And what to say about this? Kind of a tricky logic involved, especially with the requirement for the subarrays to contain at least 1 element, at least 2 elements, to contain some number of elements. I'm actually unsure of the exact logic by which the above kind of code satisfies all the requirements. This is more reliant on the correctness or the completeness of the test cases to certify that the code is correct, which is to say that I haven't put in the mental work to verify logically that this is correct, or the mental work I have put in has not fully verified, unfortunately. But anyways, time complexity, this is going to be O of n to iterate over all the indices, doing constant work. Actually, I should probably mention the summary. Basically, use separate for loops to increment a kind of global index variable and kind of individually verify that each section, kind of subarray portion, has the required increasing, decreasing, increasing structure and at least some number of values. Time complexity, this can be O, or space complexity, this is O1, since no extra space is needed. And yeah, your first subarray going increasing, making sure that you don't go out of bounds. And then at the end of that, if you haven't actually moved up, or if you're at the end, then obviously it's like all increasing or haven't increased enough, because you can't just have a single element start and then decrease from there. That just doesn't work. And then you have your middle section, your last section with similar logic.